All right, algebra. This lesson is on linear versus exponential, okay? This is from earlier in the year. All right, remember, these are the notes you should look over before you work on this page, all right? If you're talking about linear, okay, you're looking at a constant rate of change, which means you're going to add or subtract the same amount each time. Every time you're adding or subtracting the same number, the same value, okay? So an example would be you're driving at a constant rate of 50 miles per hour, okay? If it's constant rate of change, it's linear. And the units will give it away, miles per hour. Or if you were talking about how much someone charges, they charge, a plumber charges $40 per hour. When you see this type of phrase, it's talking about the rate of change or the slope. All right, versus exponential. Exponential is rapid growth, okay? You're looking for words that are going to describe multiplying or dividing. So an example of that would be the population of a species of flies doubles each week. Doubles is multiplying by 2, all right? So this is the type of thing you're looking for. A lot of times these questions are word descriptions, which one's linear, which one's exponential. Sometimes you'll get a table of values and they'll ask. All right, so look at number 1. It says table below shows the values of 4 different functions of x. Which table represents a linear function? So you're looking for something that's going to add or subtract the same amount. All right, you got to check all the values and make sure. So if I look at the first choice, it goes from 12 to 19. It's adding 7. And then it goes from 19 to 26. It's adding 7. And then it's going from 26 to 33. It's adding 7. So that's going to be linear. If you look at this one, it's adding 2, and then it's adding 4, and then it's adding 8. All right, so that's more of an exponential situation. It's doubling. All right, if you look at the next one, it's adding 3, it's adding 5, and then it's adding 7. All right, that's neither. All right, question 2. The function t of x is shown in the table below. Determine whether it is linear or exponential. All right, and if you look, each time it's going down by 2.5. It goes from 10 to 7.5, from 7.5 down to 5, from 5 to 2.5. It's decreasing by 2.5. So this one would be linear because it decreases by 2.5 each time. All right? All right, moving along. This is where most of the rest of the questions are going to look like. All right? They give you word descriptions and they ask you, which is linear, which is exponential. All right, number 3. Which situation could be modeled using a linear function? So you're looking for words that sound like you're adding or subtracting. Okay? All right. All right, a bank account grows at a rate of 5% each year. As soon as you see that percentage, that's exponential. That's the key word. Okay, choice 2. A population of bacteria that doubles. Keywords doubles. That's going to be exponential. All right, choice 3. The cost of cell phone service that charges a base amount, that sounds like your wire intercept, plus 20 cents per minute. That sounds like your rate of change or your slope. That's the linear one, choice 3. All right? And the last one, just to show you, the concentration of medicine in a person's body that decays by a factor, that sounds like multiply, of 1/3. So this is multiplying by 1/3. That's going to be exponential. All right? All right? All right, I'll do a couple more examples and then you can try the rest. The highest possible grade for a book report is 100. The teacher deducts 10 points for each day the report is late. All right? 10 points per day sounds like the slope, right? Deducts sounds like subtracts 10. All right, that's going to be linear. All right? All right, let me show you one more, then you could try the rest of these. Grisham is considering 3 situations below. And they give you the situations. Which statement describes a situation with an equal difference over an equal interval? Right? Right? They're not coming right out saying it, but this is linear because they're talking about a constant rate of change. So they want to know basically which ones are linear. All right? All right, for the first 28 days, a sunflower grows at a rate of 3.5 centimeters per day. Sounds like your slope. This one's linear. Check. 2, the value of a car depreciates at 15% per year. As soon as you see that, that's exponential. That's not it. All right, choice 3, the amount of bacteria triples. As soon as you see triples, that's exponential. All right, so which one's linear? One only. All right? So again, for a linear, you're looking for a constant rate of change or adding or subtracting. For exponential, you're looking for something that indicates multiplying or dividing, like tripling, doubling, or a percentage, right? Think percent growth or decay. That's exponential, right? Try the rest of these. Talk to you soon.